Hello friends, in this video we are going to solve a problem on how to determine the solution of a time invariant state equation. So let's take a problem. So our problem is we have to obtain the time response of the following system. The state model of the system is given to us and it is given that ut is a unit step input and the initial conditions are x10 equals to 0 and x20 equals to 0. So we have to find the time response. So let's try to solve this problem. So this is a non-homogeneous system because input u is given to us. So we know that the solution or the time response of a non-homogeneous system, it is given by the formula. So this is the formula for the time response of the system. Okay. Here e raised to the power at, it is the state transition matrix and this is equal to the Laplace transform, or we can say that it is equal to the inverse Laplace transform of Si minus A inverse. Okay. So first we will calculate the e raised to the power at. X of 0 is given to us the initial conditions and then b is also given to us in the question. U is also given that it is a unit step input. So one by one we will first we will calculate Si, this e raised to the power at, that is inverse Laplace transform of Si minus A inverse, and then we will substitute all the variables in this formula to calculate the time response. So first calculate the Si minus A. So for this we want the A matrix, and A matrix can be obtained from the question. We are given the state model x dot equals to this matrix x plus this u. So if we compare this with the standard ax plus bu, then this A, this is this matrix, B is this matrix, this is C. So y equals to cx plus du. So C matrix is this. We have got the values of A, B, C matrices. So A matrix is 0, 1, minus 6, minus 5. Now we have to calculate Si minus A. So S multiplied with the identity matrix, so all the diagonal elements will be S. Now minus I, this minus A, so this is 0, 1, minus 6, minus 5. So this will be equal to S minus 0, S, 0 minus 1, minus 1, 0 minus minus 6, 6, S minus minus 5 is S plus 5. So this is Si minus A matrix. Now we have to calculate Si minus A inverse. So inverse is equal to adjoint divided by the determinant of Si minus A. Now for calculating the adjoint, what we have to do, just we have to interchange these two elements, and these two elements we have to change the sign. So it will become s plus 5, this is s, this will become minus 6 and it will become plus 1. Divide by the determinant. So determinant will be s multiplied with s plus 5 minus of 6 multiplied with minus 1. So minus 6, it is s square plus 5s plus 6. So it will be s plus 2, s plus 3. So here we are going to divide this with s plus 2, s plus 3. So now the inverse of si minus a will become so this is the inverse of si minus a. Now we have to calculate the inverse Laplace transform of this matrix. So inverse Laplace transform of Si minus A inverse will be inverse Laplace transform of this. So we have to change these terms into the standard form so that we can apply the formulas for the inverse Laplace transform. So we are going to calculate the partial fractions of all these terms. Now partial fraction of s plus 5 upon s plus 2, s plus 3, how we can obtain? This will be equal to a upon s plus 2 plus b upon s plus 3. Taking the LCM, multiply these. So the denominator terms are same on both the sides. Numerators we are going to compare. So the coefficient of s here is 1 and the coefficient of s here is a plus b. So it will be equal to 1. Constant term here is 5 and here constant terms are 3a plus 2b equals to 5. So we have two equations and two unknown variables, so we can easily find out the value of all these. So a will come out to be 3 and b will come out to be minus 2. Okay, so we are going to substitute these values here and we will get the partial fraction of this term. So in this way we are going to calculate the partial fractions of all the 4 terms. Then we can easily apply the inverse Laplace transform formulas. So I'm directly writing the partial fractions of all these 4 terms. Now we are going to apply the inverse Laplace transform on all these 4 terms and we can calculate it. So inverse Laplace transform of Si minus A inverse. This is the its inverse Laplace transform will be 3 e raised to the power minus 2t minus 2 e raised to the power minus 3t. Here we have okay. So this is the inverse Laplace transform of Si minus A inverse, or we can say that it is e raised to the power a t. Okay. Now we have the formula for the time response which we have written in the starting of the solution. So this xt, it is given that xt is equal to e raised to the power at x0. Okay. Now here we have calculated e raised to the power 80, and we have to, this x0 is also given to us, that x0 is equal to 0 and 0. The initial conditions are 0. And this we can calculate. We have to just replace this t by t minus tau. So we are going to get a multiplied with t minus tau. B is given to us in the question. It is 0 and 1. U is also given, that we have the unit step function, so U tau will be 1. Okay, so substitute the values of all the variables in this formula and then solve it to get the xt value. First we will write e raised to the power 80, which we have calculated here. Okay, so we will just copy its value here. This is e raised to the power 80. Then x0, it is 0 and 0. Plus, we have to write the e raised to the power 8 t minus tau, and then this integration has to be applied over this. So integration 0 to t, and then this e8 t minus tau. So instead of t, we will write t minus tau. This is e raised to the power 8 t minus tau. Then B matrix, it is 0 and 1. Then U tau, it is 1, and then D tau. So 1 into D tau. Okay. Now, when we multiply these two matrices, then this multiplied with 0, this multiplied with 0, it will become 0. Second row and this column, so this multiplied with 0 and this multiplied with 0. So this whole term is going to become 0. Now here, if we multiply these two matrices, then this term multiplied with 0 plus this term multiplied with 1. So first term is going to become 0, second term is only left. So we will write here 0 to t. This multiplied with 0, it will become 0, and this multiplied with 1. So we are left with now second row and this column. So this first term multiplied with the first term, it has become 0, and second term multiplied with this term. So only this term is left. Okay, and on whole this we have to apply this d tau. Okay, now we are left with this integration. So now we are going to individually solve it. This is xt, this is x1t, this is x2t. Okay, so x1t will be equal to integration from 0 to t, and this first term and d tau. Okay, so now here we are going to suppose that this minus 3t minus tau, it is equal to x. Okay, just to solve this, to simplify this, we are doing it. So put minus 3 t minus tau as x. Okay, so when we are supposing this, then limits are going to change. We will check the limits. When tau is equals to 0, If we put 0 here, tor is equals to 0 here, so x will be equal to minus 3t. And the second limit is when tor is equal to t, the upper limit. So when tor is equal to t here, so x will be equal to 0. So now this expression, this e raised to the power minus 3t minus tor will be changed. So if we take the differentiation of this d tor will be equal to 1 upon 3 dx. Okay. So this whole expression, this e raised to the power minus 3t minus tor d tor, it is going to change. How? Let's see. This 1 by 3 dx, we will write it in the terms of, we will write this expression in terms of x. So it will become d tor will be replaced by 1 by 3 dx, and t minus 3t minus tor will be replaced by x. So it will become, limits are also going to change because these limits are for tor, and now we are getting the limits for x. So when tor was equal to 0, x is equals to minus 3t, so the lower limit will become minus 3t. And when the tor is equals to t, then x is equals to 0, so the upper limit will become 0. And then the inside expression, that is e raised to the power minus 3t minus tor, it is changed. It will become e raised to the power x, and then d tor is replaced by 1 by 3 dx. So 1 by 3 is written outside and dx inside. So this expression we have got. Now if we solve this, it will become, apply the higher limit, that is e raised to the power 0. So it is 1 by 3 minus the lower limit is minus 3t. So it will become e raised to the power minus 3t. So we have broken this x1t into two parts, and both the parts we will solve. First we have solved this second part. Now similarly we are going to solve this second part. Same thing we are going to do. We are going to put minus 2t minus tor as x. Then tor is equals to 0. When tor is equals to 0, x will be equal to minus 2t. And when tor is equals to t, x is going to equals to 0. Then d tor will be equals to 1 by 2 dx. Okay. So this expression will become, this first expression, first part, it is going to become, limits are going to change. It is becoming minus 2t to 0. Just like this. 1 by 2 minus 2t 0 e raised to the power x dx. So when we are going to solve this, we will get it as 1 by 2 minus 1 by 2 e raised to the power minus 2t. So this x1t, we have broken it into two parts. We have assumed another variable, and then we have solved this whole integration. So x1t will now become, first is this part. So 1 by 2 minus 1 by 2 e raised to the power minus 2t. And second we have minus sign and this second expression. So second expression we have got, it is 1 by 3 minus e raised to the power minus 3t. So x1t is going to become 1 by 2 minus 1 by 3. So it is going to, if we take the LCM, then it will become 1 by 6. Then minus 1 by 2 e raised to the power minus 2t, minus minus plus sign e raised to the power minus 3t. So we have got x1 t here. Now similarly, we are going to solve this second part because this xt we have to solve. This was x1t and this is x2t. And here we have just solved x1t here. Okay. Now x2t, Similarly, we are going to put the variables and then we are going to solve it. Now this we have already done, e raised to the power minus 2t minus tau, and this already we have done. So we are just going to multiply this minus 2 and this term we have got here. This was there. So we are going to place its value plus 3. This we have calculated. So just simplify it. If we solve this, we are going to get e raised to the power minus 2t minus e raised to the power minus 3t. So this is x2t. So we have to calculate xt. So put the value of x1 and x2 here. So this is the time response of the system. Now, if we want to calculate the output response, then output response is equal to y equals to cx. Y, c is given to us in the question, it is 1 and 0. X we have calculated, that is the time response what we calculated here. So substitutes its value. Multiply these two matrices. So 1 multiply with this and 0 multiplied with this. So output response will be equal to So this is the output response of the system. So we have calculated both the time response and the output response of the system. So whenever you have any type of problem in which you have to calculate the time response of a non-homogeneous system, so just take the formula, you know the formula for it, and then calculate all the variables in it. First the state transition matrix, and then the output response can be calculated by y equals to cx. So just calculate the state transition matrix and then substitute the value of B matrix and the input, all the variables you can calculate and substitute it in the formula to get the time response and the output response of the system. So I hope that you can solve these types of problems and it is understood to you. So thank you.